everyone, welcome back. It's great to have you here today. Today we will be looking at numbers. Please get your pen and paper ready and work through these questions with me. Okay, so in this video we are going to look at standard form, conversion between fraction and division, or round number to one decimal places, one significance figure, or truncation. And finally we'll be talking about the range of values. Okay, so first let's look at standard form. Standard form is an easy way to write a large number or a smaller number, and what we need to be able to do is to make sure we know how to convert numbers in standard form. So for example, in this question, we need to find out whether this conversion is correct or not. So the first one is incorrect. It's because for the first number, we have been divided by 10, and then for the second number, we also divided by 10. So that means the number is getting 100 times smaller. Instead, if we wanted to write it as 34.2 times 10 to the power of something, we should be multiplying 10 to the 7 by 10 to get 10 to the 8. Moving on to the next one. 253 times 10 to the negative 5, does that equal to 25.3 times 10 to the negative 4? The first number has been divided by 10, however the second number has been multiplied by 10, therefore this is correct. The last one, 0.0056 times 10 to the 23, does that equal to 0.056 times 10 to the 24? Well, the first number has been multiplied by 10, the second number has been times by 10 as well, therefore this is incorrect. In order to write down the correct answer, we can write it as 0.056 times 10 to the 22. What we need to also be able to do is to be able to multiply, divide, add, and subtract two numbers that are in their standard form. So what we are going to do here is to look at the multiplication first. 3.5 times 10 to the negative 6 times 6 times 10 to the 11. Because multiplication is commutative, what we can do is to write this multiplication as 3.5 times 6 times 10 to the negative 6 times 10 to the 11. 3.5 times 6 is 21, and then 10 to the negative 6 times 10 to the 11 is 10 to the 5 by using rules of indices. After we write down the answer, we need to check, see if this number is in its standard form. 21 is bigger than 10, therefore we can write it as 2.1 times 10 to the 6. Now let's look at division. One way to look at this problem is to write this division as a fraction. So we will have 4 times 10 to the 7 over 8 times 10 to the 2. If we multiply two fractions together, we multiply the numerators and the denominators. So that means I can split this fraction into 4 over 8 times by 10 to the 7 over 10 to the 2. So 4 over 8 is 0.5. 10 to the 7 over 10 squared is 10 to the 5. Now let's check. 0.5 is smaller than 1. Therefore, it's not in its standard form. We can multiply this by 10. That means we have to divide 10 to the 5 by 10 to get 10 to the 4. Now let's look at addition. Before we add two numbers together, what we need to do is to make sure that we have the same unit. So 10 to the 21 and 10 to the 20, they are different. So we can divide 10 to the 21 by 10 to get 10 to the 20. However, if we wanted to make sure the numbers are the same, we needed to multiply the first number by 10 to get 27. We can write this calculation as 27 times 10 to the 20 plus 3.1 times 10 to the 20. Now we have 27 lots of 10 to the 20 and 3.1 lots of 10 to the 20. In total, we will have 30.1 lots of 10 to the 20. This is not in its standard form. We can divide the first number by 10 to get 3.01 times 10 to the 21. Let's move on to look at the subtraction. This is similar. What we need to do is to make sure that 10 to the power of something is the same. So we are going to divide the first one by 10 to get to 10 to the 8. That means the calculation can be written as 22 times 10 to the 8. Subtract 4.8 times 10 to the 8. 22 lots of 10 to the 8 subtract 4.8 lots of 10 to the 8 is 17.2 times 10 to the 8. Write it as a standard form, it's 1.72 times 10 to the 9. Of course, you can convert 10 to the 8 to 10 to the 9, and then you will be able to get the same answer. Okay, so now moving on to the second part, where we look at the conversion between fractions and decimals. To convert fractions to decimals, there are two different methods. For example, 7 over 20. Now, if we can write this fraction as over 100, that means we'll be able to write it as decimals easily. I can multiply numerator and denominators by 5 to get 35 out of 100. Then, as a decimal, this is 0.35. For example, if we have something like 5 over 8, to write it as out of 100 is not so easy, but fraction is really division. So 5 over 8 is the same as 5 divided by 8. We can now use bus stop method to convert the fraction. There's 0 lots of 8 goes into 5. So then we have 6 lots of 8 going to 50. That gives us a remainder of 2. And then there are 2 lots of 8 goes into 20, remainder of 4, and 5 lots of 8 goes into 40 with the remainder 0. Therefore, 5 over 8 can be written as 0.625. Now, if we wanted to convert decimals into fractions, one way of writing this is to write it as fractions out of 100 or 1,000. For example, 0.275 can be written as 275 out of 1,000. Now we need to simplify this fraction by dividing numerator and denominator by 5, and then further divided by 5 to get 11 over 40 as the simplest form. Now to convert the recurring decimals, there is a trick. So for example, if I need to convert 0.5 recurring as a fraction, what we can do is we can let x be 0.5555 recurring. I must use ... to show that it is a recurring decimal. Now, if I multiply that x by 10, we will have 5.5555, etc. Then 10x take away x is 9x. 5.5 recurring subtract 0.5 recurring, that leaves us with 5. Therefore, x is 5 over 9. Similarly, if I have 0.31 recurring, I can let x be 0.313131 recurring. 100x is 31.313131. So 99x is 31, x is 31 over 99. Moving on, 0.312 recurring. Now in this case, only 1, 2 is recurring, 3 stays the same. So x, if I write it out in full, it should look like this. X is 0.312121212 recurring. So let's have a look. What should I multiply that x by? If we multiply by 10, we will have 3.121212. As you can see, they don't line up. If I do 10x subtract x, I won't be able to get rid of that 1, 2 recurring. So let's try 100x. I'll have 31.212121. This allows us to get rid of that 1, 2 recurring. So 99x is going to be 31.2 subtract 0.3. And that gives us 30.9. X is 30.9 over 99, which is 309 over 990. To simplify this fraction, we can divide numerator and denominator by 3, and that gives us 103 over 330. Okay, so now let's look at this one, 0.312 with dots on top of 3 and 2. Now this means 3, 1, 2 are recurring. So x is 0.312312 recurring. Similarly, we can try to multiply it by 10. As you can see, the recurring parts don't line up. Let's try 100x. As you can see, it still doesn't line up. So let's try 1000x. Now this time, we will be able to get rid of the recurring parts. 999x is 312. So x is going to be 312 over 999. And then simplify this fraction, we have 104 over 333. Okay, so now let's look at estimate or rounding. In the first one, I wanted to round this decimal to 3 decimal places. After the decimal point, we needed to look at the first 3 numbers. Draw a line. Let's look at 4. If the number after the line is smaller than or equal to 4, we do not round the previous digit up. In this case, it's 3.125. If we wanted to round this number to 2 decimal places, then we'll look at the first 2 digits after the decimal point. 5 is greater than 4. We are going to round the previous digit 2 up. So the answer is 3.13. If we wanted to round this decimal to one significance figure, similarly, we are going to look at the first non-zero digit, which is 3, and then look at the number after that, which is 1, and that is smaller than 4, therefore previous digit stays the same. If we wanted to round this number to 2SF, Then we will look at the first two digits, which is 3.1. Well, 2 is smaller than 4, therefore this number stays the same. So let's talk about significant figure. When does 0 count? Okay, so all non-zero digits are always significant. So for example, 2, 3, 5, 7, 2, 1, they are all significant. Zeros between non-zero digits are always significant. So these three zeros between 5 and 7 are significant. Leading zeros are never significant. So 0.00 doesn't count. Zeros at the end are only significant if the number contains a decimal point. So for example, in this case, the final four zeros are not significant. However, if I add a decimal point, then these zeros will be significant. So 0.002 is 1 SF, 0.2001 is 4 SF, 20,000 is 1 SF, however 200.0 is 4 SF. Let's talk about truncation. Truncation is a way to estimate the number without doing any rounding. So to truncate a number, we simply miss off digits past a certain point in the number. So for example, if I want to truncate this number to one decimal place, it's going to be 3.7. Even though that 8 is greater than 5, I don't round it up. Now, if I want to truncate this number to two decimal places, I'll simply chop off what's after 0.78. The answer is 3.78. However, sometimes we need to fill in zeros to make the truncated number approximately the same size as the original number. So for example, if I wanted to truncate this number to 3SF, which is 638. Now I can't just write it as 638 because the number obviously is 63,000. Therefore, we have to add two zeros to the end to make sure that the numbers are of the similar size. Okay, so now moving on to range of values. If x is rounded to one decimal place, that means x can take any value between 2.5, including 2.5, and 3.5, however, not including 3.5. It's because if the number being in 3.5, then it will round to 4 if it rounded to one decimal place. If y is 2.4 to one decimal place, then y can take any value between 2.35, including 2.35, and 2.45. If we wanted to find the range of x plus y, now what we need to do is to find the smallest value that x plus y can be and the largest value x plus y can be. So to find the smallest value, what we will do is to add the smallest value of x and y, and that's 4.85, the largest value of x and y, which is 5.95. If we wanted to find the range of value of x subtract y, now what we need to think about is how to get the smallest possible value. What we need to do is to use the smallest x value, subtract the largest y value, and then in order to find the largest value for x subtract y, we need to use the largest x value, subtract the smallest y value. So x subtract y is going to be between 0.5 and 1.5. Moving on to the next one, if we wanted to find the range of value for xy, now in order to get the smallest value of xy, we multiply the smallest value of x and y, and to find the largest value of xy, we multiply the largest values together. However, if we wanted to find the range of values of x over y, what we need to do to find the smallest value is to divide the smallest value by a larger value, which is 2.5 over 2.45. And to find the largest value of x over y, we need to divide the largest value by a smaller value, which is 3.5 over 2.35. Okay, that is it for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport, and we have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.